In the last video, we looked at calculating the pH of a strong acid. This time we're going to do kind of the opposite, where we're given the pH and we're asked to calculate the concentration. And now again, these are going to be strong acids. So if I know the concentration of the hydrogen, or H3O plus hydronium, it is the same as the concentration of the original acid because it dissociates 100%. And so this time, again, we're given the pH and I want to know the concentration. But if we backtrack and kind of look at number one, when the pH was 3, where did that come from? Well, I could directly tie that back to the exponent of 10. pH is opposite log or opposite exponent of 10. So you can just take that pH value and throw it up there as the negative exponent of 10 and you're done. That seems too easy, right? That's it. That's what to do. So I could take this pH 6 and say the concentration is like 1.0 times 10 to the negative 6 molar. Done. And again, that is H3O, which is the same as H plus. These guys would be the exact same numerical value. You really are done. That's it. Sweet. Now, if I have something that's decimal or fractional in my pH, so it's a pH of 7.4, you start out the same way, and I think, okay, well then let's just put that up there as the negative exponent of 10. 1.0 times 10 to the negative 7.4 molar. And this would be some kind of an acid, maybe it's HCl or HNO3 or something like that. Now, here's the only trick with these decimal pH values. It's a little taboo to leave a decimal as your exponent. So you need to plug this in your calculator and let your calculator simplify it for you. So when I plug this in, I'm just going to type in to my calculator 10. Yeah, I mean, obviously you can skip the 1.0. And then I'm going to hit that caret key, 10 to the, then go negative 7.4. And again, this is something that you got to try. You got to try this in your calculator sometime between now and whenever we do an assessment, just to make sure that you are typing it in the way your calculator wants it to be typed in. So if I do that, I plug it in, 10 caret, negative 7.4. Now my calculator gives me about, I'm going to say 4.0 times 10 to the negative 8. Again, it's HCl or some kind of acid. That's my final answer. My calculator will simplify it so that there's a whole number in the exponent, but it might just not be a 1 out in front. That's okay. Here, this just is what it is. 10 to the negative 6. In the end, we just don't want decimals in our exponent. You can think of it the same way, just go 10 to the negative pH, but then let your calculator simplify that for you. Okay, so here's this extension, and I want to see if we can kind of squeeze this in. There's a question that shows up, oh gosh, in the homework somewhere, a little practice problem somewhere, and it's so great, and people suck at it all the time, but you won't because we're going to mention it. The problem looks something like this. It'll say we have, oh gosh, let's make up a number. Let's say like 25 milliliters of HCl with a pH of, oh gosh, I think the one I'm thinking of in my head is around 1.5. Let's say it's 1.5, 1.50, something like that. Okay, so we've got this initial hydrochloric acid solution. There's like 25 milliliters, and the pH is about 1.5. Then it says something like the solution is diluted to, let's make it about 200 So somebody's adding water to that 25 milliliter sample. They're going to dilute it to a total volume of 200 milliliters. Let's say 200. I might even add that in there. 200 milliliters total volume. There. The question then says, what is the new pH? And man, do I get blank stares. Like, what are you talking about? There's two things going on. We're diluting a solution. There's a dilution equation. And I want to do a pH. There's a pH equation. So what happens first? Eventually, I want to do something that's going to look like, whoa, like this. Come back to me. There it is. Eventually, I want to do that dilution equation, that M1V1 equals M2V2. And we know a few things. I do not know the original molarity. I have the original volume, 25. Oh, I don't have the final molarity either. But I do know the final volume. Let's say it's diluted to 200 milliliters total volume. Well, secretly, you do know the initial pH. You do know the initial pH. You secretly know the initial molarity. And here's where people get stuck. But I don't have enough variables. I don't have enough data to plug into this equation. Oh, but you kind of do. If you know the pH, you know the molarity. All I got to do is then say that the molarity is like 1.0 times 10 to the negative 1.5 or 1.50, which again, it's a little taboo. And so we would plug that in our calculator. So I just plug into my calculator. I'm going to skip the 1.0. I'm going to go 10 caret negative 1.5. And my calculator says 0.0316 molar. There's the initial molarity. And people forget that all the time, that if you know the pH, you know the molarity of the solution. So they might give us an acid. And so here's like one step beyond what we did in the last unit, where instead of just telling us that it's 0.03 molar, they're telling us the pH. But that's not going to trip me up. If I know the pH, I know the molarity. So now I can plug that in. The initial molarity is about 0.0316. The initial volume was 25 milliliters. I do not know the final molarity, but I know the final volume. Let's say it's diluted to 200 milliliters total volume. So somebody must have added 175 milliliters of water. Cute. Okay, so if I plug that in my calculator, I'm going 0.0316 times 25 divided by 200. And I get M2 as about, 0.00, I'll go maybe 3 sig figs-ish. I'm kind of making this problem up. 395. And it's really similar to one that's in the homework. All right, cool. So there's the final molarity. And if you know the molarity, you know the pH. Sweet. So now that I know the new molarity, I can say the new pH is just opposite log of 0.00395. There. So I can plug that in to my calculator. Opposite log 0.00395. And I get about a 2.4. Oh, is that good stuff? This is like complex. This is good stuff where you're combining a few concepts here that, I mean, first I had to be able to get the initial molarity given the pH, which that alone could be like its own question if it were like a simple or essential. Then I have to be able to do the dilution equation to figure out the new molarity, and then I can plug that molarity into the pH equation. And it makes sense that if I diluted the solution, it should be less acidic. There's less hydrogen per volume. And so it makes sense then that the pH is now 2.4, less acidic than the initial pH of 1.5.